of coordinates of its own. But to some, finding a way around the world, it's a challenge. The point here is that some things are strictly a question of point of view. Like defining origin. It isn't universal. We define our own origin. And then to locate where something is with respect to our point of view, we draw axes. A-X-E-S, plural. Let's assume that the captain had some physics instinct. He would then probably determine his approximate distance from the Coast Guard base, say 200 kilometers, which would leave me with a range to look for him. He could be anywhere in this region. But you know what? Giving the distance from a point to reach somewhere specific, it's not a great idea. Especially in such cases. It is kind of incomplete information. The complete information would be something more specific which tells me how much and which way. Ergo, magnitude, direction. Focus on that. And we call this complete information, drum roll, vectors. Familiar? I know you've heard this before. For example, force. Let's say we applied 10 Newton force from the top and 10 Newton force from the bottom. Can you see that? Intuitively, we can say that the net effect is 0. Or I could apply 10 Newton and 10 Newton from the same side. Intuitively again, the net effect would be 20. Let's sum it up what we have done so far. If 10 Newton and 10 Newton are in the same direction, the net effect is 20. If 10 Newton and 10 Newton are in opposite direction, the net effect is 0. Let's look at another arrangement. 10 Newton in the direction shown and another 10 Newton in specific direction. I don't know how much the sum is in this case, but I know for sure what it's not. A, it's not 20. B, it's not 0. Again, I know it's not 20 and it's not 0. So I know what it's not, but I have no idea what it is. If you are settling on that, let me give you another example. Listen carefully. Electric current. How about now? Right. 2 ampere and 1 ampere in both the cases, whether the wires are like this or the wires are like this, in both cases, 2 ampere and 1 ampere is giving me 3 amperes. Something is off. Yes. We need to redefine the idea of vectors. Yes, they have magnitude. Yes, they have direction. There is something else. And that something else is that they have their own vector algebra. So then, what are scalars? Everything that's not a vector must be a scalar? Are you trying to say that every quantity in the world can be categorized as a scalar or a vector? Everything in this world is either scalar or vector? Well then, what do you categorize love and hatred as? Envy? Jealousy? Rationality? If someone asks you how much you love them, the answer is a lot. But can you quantify? Can you attach a number to the love? How about hate? I hope not. But can you attach a number to the hate? Or can you love someone in northwest direction or southwest direction? You can't. There you go. More precisely put, physical quantities, quantities which can be quantified and expressed numerically, they can be categorized as either scalars or vectors. We have just learned that there are 3-pronged criteria to call a physical quantity vectors. Magnitude, of course. Direction, for sure. The third one is a new entry. It should follow its own laws of algebra or vector laws of algebra. Obviously, we are curious to know what are these vector laws of algebra, and in order to understand that, we must first learn how to represent a vector. How to represent a vector on paper. We have two broad ways to represent a vector on paper, which will facilitate the algebraic operations later. Number one, pictorial or graphical representation. Number two, symbolic or textual representation. A picture is worth 1,000 words or texts. So clearly, the first one is the more detailed one. So let's begin with that. Let's understand graphical or pictorial representation. Let me appeal to the most intuitive part of your response when I say vector. Who is teaching you? I am. Who's studying? You are. Did you just see how intuitively I pointed at myself? How intuitively I pointed at you? Let's say you're walking down the street and you ask someone that where is this comic book store or where is this blah blah coffee shop? So the good Samaritan says that blah blah coffee shop, it's over there. Let's say you can't locate that. You'll say, where? Over there. When a person tries to accurately describe something which is far off, usually you bend backwards, over there. But that's besides the point. The idea is, what do you mean by over there and not over there? Why did you just make index finger point at that place? Because you are trying to mimic an arrow. Vectors on paper are drawn using straight lines with precise arrow pointing at the precise direction. In order to talk about this in much detail and precision, let's establish the sense of direction first. So, north, south, east, west. Okay? How does one locate 1 centimeter in west? Let's say displacement. Simple. Okay. How does one locate 1 meter in west? Draw a longer line. How long? Why not 1 meter? Okay. How does one locate 1 kilometer in west direction? Now there is a problem. 1 centimeter, okay, I could draw. 1 meter, I could draw. So 1 kilometer, wait, come back. That's not practical. Yes, on paper, vectors are represented by a straight line representing its magnitude and the arrow pointing at its direction. But how long is that line? Clearly, if I have to deal with a 1 kilometer vector, the line can't be 1 kilometer long. Let me clarify that for you. Let's compare two displacement vectors. One is 1 kilometer west and the other is 5 kilometer north. Now watch carefully. If a single vector needs to be drawn, any comment on the length of the line is arbitrary. But if I have to compare, it's not arbitrary anymore. There is a rule of thumb there to follow. On a graph sheet, if I'm plotting 1 kilometer west, let's say 1 block, 1 unit represents 1 kilometer. So draw the vector pointing towards west. How long will be the 5 kilometer vector in north? Yes, it will point north. Fine. How long? 5 units. Do you see? It is in your power. It is in your hand to establish the monomer, the basic unit. But if multiple vectors are being compared simultaneously, once you establish the standard, stick with it. In a nutshell, Length of the vector could be arbitrary, but proportional. It means that if you're comparing two vectors, their length should also be in the ratio of their magnitudes. I hope I have made that point clear. Let's explore the world of direction a little bit more actually. Because north, east, west, south, I mean, not 4 directions is going to cater to all possible values, is it? How about a vector is in northwest? Northwest, yeah, the angle bisector between the north line and the west line. Absolutely. This vector is in northwest. How about this vector? Can you see it is not exactly the angle bisector? Can you tell me the direction of this vector? Well, I don't know in what direction this vector is, but I know for sure in what direction this vector is not. It is not northwest because it is not angle bisector. So what do we do now? We need more information, right? Let's say now. Can you see it makes an angle 30 degree with the north line? Now tell me the direction of this vector. That's right. This vector makes an angle 30 degree with north. Wrong. Because there are 2 possibilities to make 30 degree with north. That side and closer to me. Be specific. 30 degree west of north. Absolutely. Now it makes sense. This vector is 30 degree west of north. I know what you're thinking, and you are right. Is this vector also 60 degree north of west? Absolutely. And if this was your thought, bravo, you have understood this. West of north, that means from north towards west. North of west, that means from west towards north. So summarizing, in pictorial representation, in graphical representation, a vector is always drawn with a straight line with a clear arrow pointing in the respective direction. Notice, a line has 2 ends, right? The end with the arrowhead on it is actually called the head of the vector. And this will be our lead up or segue to the second mode of representation, that is textual or symbolic representation. Okay. Inform about this vector. I know it's drawn. Inform someone about this vector without using the picture. Symbols. Can you? No, you can't. How can we do it then? Let's assign symbols to both sides of the vectors. Let's call the tail capital A. Let's call the head capital B. This vector, when written in symbols, will be written as AB. AB. But AB was a line segment. Back when we were learning about mensuration, line segment and everything, we heard AB is a line segment. How is that line segment different from a vector? The direction is from A to B. How do I express that part in my symbol? The answer is literally with the vector sign. Draw an arrow on top of AB. How do you pronounce this? AB vector? Correct. Vector AB? Correct. Modern books use AB bar or bar AB. AB with an arrow on the top will represent a vector from A to B. Clearly notice, the first symbol, the first letter is the tail of the vector. The second letter is the head of the vector. I like to understand it this way. The one ahead is the head, the one behind is the tail. So symbolically, a vector is represented as AB with an arrowhead on the top, which represents vector quantity. Clearly, what do you prefer? Graphical or pictorial? Actually, you don't have to choose, because when you have the representation of the vector in front of you and you want to add that, symbols come into picture. To visualize, see the picture. To add, use the symbol. Vector A and vector B represent forces acting on a body. If A bar has a magnitude of 5 Newton, then comment on the magnitude of vector B. Now, if the question stops here, seems really arbitrary, random, isn't it? But there is one line more, and that is the key to the question. So before looking at the diagram, let's read the last line. Length of the arrows are in proportion with the magnitude. What does that mean? What do you mean by in proportion? Does that mean that anything which is a 5 units magnitude, it has to be drawn 5 units in length as well? Well, not exactly. Not exactly. Whenever you're drawing a graph, nobody forces you to choose a scale, isn't it? Otherwise, where is the freedom to choose? But when you make a choice, you stick with it. What does that mean? It means if I have to draw a 5 Newton force vector on a sheet, am I allowed to represent 1 centimeter of length representing 5 Newton? 100%. You are allowed. But if you have called that 5 Newton is represented by 1 centimeter, then automatically, by default, 10 Newton will definitely be represented by 2 centimeter. Did you get that? You are allowed to use monomer. Monomer is your choice. Polymer is a given. Least quanta is your choice. Extrapolation, the choice has been made for you. Got it? Now tell me, look at vector A and vector B carefully. What do you think is happening here? Well, I think B is longer than A. Nice. In fact, if I look closely, A is using 1 length of a square and B is using 2 length of the square. So can I take a leap of faith and say, looks like magnitude of B is double the magnitude of A. It does look like. But who cares what it looks like? What matters is the options. Read it. B has magnitude less than 5 Newton. Nah. B has magnitude more than 5 Newton. Well, so far so good. It's correct. Let's go on. C. B has magnitude of unity. Well, there is no way of knowing that. In fact, right now, absolutely not. Because if A's magnitude is 5, B is definitely more than 5. D is can't be determined. Well, it can be. Which is the best option looking here? If they would have asked me double, I would have gone for that. But in the given choice of option, I do have option B, which is looking the most apt option. So, the answer to this question, by virtue of length of the arrows being in proportion with their magnitude, B has a magnitude more than A. But what is A's magnitude? 5 Newton. Hence the answer is magnitude of B is definitely more than 5 Newton. To sum up, what is the key fundamental out here? Whenever you draw vectors on paper, you take care of 2 things. A, they have to be drawn with straight line with arrow on the one side, that is the head representing the direction of the vector. And second, and the most important thing, when multiple vectors are drawn simultaneously, you are allowed to choose the scale you want, but then all the length have to be in the ratio of their magnitudes. And once that is sorted, you can compare their relative magnitudes. The answer for this one is B. Magnitude, direction, and follows vector laws of algebra. Not only that, we have also learned how to represent a vector pictorially or symbolically. Time to have some fun. Time to discuss some properties of vectors and have fun with it. Okay? All right. Let me establish some rules out here. Top is north, bottom is south, this side is east, and this side is west. Okay? All right. Consider a vector on your screen. Here we go. Vector AB. What if I interchange the head and tail? What if I take the arrowhead and put it on the opposite side? So initially it was vector AB. Now it is vector BA. What's the difference? Did anything change? Did the length of the line change? Actually, did the magnitude of the vector change? No. That's correct. What changed is the direction. BA vector is pointing exactly opposite to where AB vector was pointing. In other words, can you think of a mathematical relationship between AB vector and BA vector? Correct. AB vector is minus of BA vector, or BA vector is minus of AB vector. How about we cement this idea, reinforce this idea with the help of a very simple example. Out here is a load kept on the ground to be moved. And let's say a person has 100 Newton worth of effort to provide. Option number 1, push. 100 Newton push. Option number 2, 100 Newton pull. What's the difference? Isn't the 100 Newton common? So what's the difference between push and pull? Exactly, only the direction. So by switching the sign mathematically or by reversing the arrow, what you change is not the magnitude but only the direction. Fun, isn't it? All right, let's go ahead. Discuss some other property of vector. For this, I need 2 volunteers, 2 vectors. One would be this guy. And for the sake of better representation, let's assign physical quantity to them. We were talking about force just now, right? Let it be force. So this vector is 10 Newton. And where is it pointing? This side. What's the name? West. And the other vector is here. Value 10 Newton. That means force vectors. Where is it pointing? Looks like also towards west. Assign symbols. AB, CD. Tell me. Express vector AB, please. Express vector AB. 10 Newton west. Express vector CD. 10 Newton west. Can you see and register 2 different vectors? Yes. 10 Newton west, 10 Newton west. How are they different? Something is amiss. First of all, are these 2 vectors different? That's the fun part of it. Let's take the vector AB and put it down. In doing that, in translating that vector, did I change the direction part of it? Isn't the entire trail of the vector movement always along the west? Did I change the westness of it? I didn't. Did I change the 10 Newton of it? I didn't. So by translating this vector, neither the 10 Newton part changed, nor the west part changed. Vectors can be moved. Vectors can be translated. And it looks like I'm allowed to move only in the plane. My plane or your plane or the plane of the screen. That's not true. I can Pull it closer to me. Did the 10 Newton change? No. Did the vastness change? No. I can push it towards you. Did the 10 Newton change? No. Did the vastness change? No. Vectors are movable in plane, space. Vectors are movable in space as long as you don't change the magnitude and you don't change the direction. In other words, AB and CD are not different vectors, same vectors. Now, that's really interesting. Tip of the iceberg. Let's move on to even more interesting part. For that, I need to take a cut and re-establish some rules. Take a vector first. Okay. Here is a vector. This vector belongs to your world, let's say. This vector is kind of plastered on your screen, if you will. Okay? And now I come with my set of rules and try to express the vector. Do you understand something? Chronologically speaking, the vector already existed. I am the new one. Okay? I have come here with my rules. What are my rules? North, south, east, west. I am trying to express this vector with this set of rules. Well, if this angle is 45 degree, the vector is along northwest. Let's not care about what this vector represents. Could be velocity, could be force, could be displacement. Doesn't matter. Okay? This vector is along northwest. Now, what if I, along with my set of rules, tilt? Are you ready? Actually, you are ready. I have to be ready. It's gonna get bumpy. Whoa. Okay. Where is the vector now? Looks like along north. Okay. Can you please go back? Oh, all right. Back to northwest. What changed? Did the vector change? No. Vector was already existing. I, along with my set of rules, changed. The previously northwest vector became momentarily a vector along north. Magnitude, no change. Direction, looks like change. Previously it was northwest, then it became north. Clearly it changed. No. Description changed. Do not confuse between direction and description. What used to be northwest became north for me. That is my problem, not the vector's problem. Let's do it one more time. This time, oh God. Okay. Where is it now? West. Can we please go back? Okay, thank you. Back to northwest. Vector AB was along northwest. Vector AB became along north. Vector AB became along west. It was the same vector AB pointing in the same direction. It's just choices changed, reference changed, axis changed. If you change axis and origin, you are not changing the vector, you are just changing the way you describe it. And that was some part of the fun with vectors. Stay tuned for more. How does a vector change? That's a random question. That's okay. It's okay. If we are confused somewhere about the actuality or accuracy of a question, we will work under the assumption. But the condition is, whatever assumption we work with, we state them out loud. Let's work, you and me together, all right? So how does a vector change? What does change means? Well, last time I checked, vector has a magnitude and a direction. So if either of it or both change, the vector will change.
Perfect. Clearly, they have given us options which are representing situations, and we have to ascertain which situation can bring about change, isn't it? Nice. Okay, so let's start with the first one. By changing the length of the vector, obviously, if the length of the vector is changing, pray tell, what is actually changing? Magnitude. And if the magnitude of the vector is changing, well, the vector is changing. So yes, option